Okay, well, good morning, everyone. So today we're going to talk about the very exciting world of mail. Actually, we are really excited about this just because in the product for a long time we've had technically what you would call IMAP and SMTP, but what's replaced, it got to a state, because Visual Age VA has had such a long history that and logging into servers for mail has changed so much. So what was there was really hard to, some of the abstractions weren't laid out appropriately, and you could hardly really log into current mail servers without, trying to tell your mail server to be extremely insecure and just so you could be able to do it. So being able, this was by customer demand, being able to send mail. I kind of at one point collected all the support cases together and saw that we were not able to answer to proper SMTP and IMAP support, and folks were going out to things like curl and to be able to do these things. And we wanted to be able to offer something in-house to do this. So what we came up with is pretty cool. So it actually turned into a more generalized framework for on top of our kind of server smalltalk framework. And it actually go up one more abstraction level next time to support even non-mail things like FTP and this kind of stuff. But we're coming together with some nice abstractions that are uniform. If you want to do HTTP, IMAP, SMTP, LDAP, whatever it is, you're kind of working with things the same way. So just a little bit, most of this will be tour by examples, so I'm going to be just going into the development environment, showing off some, along with the new support, we wrote an examples application, which kind of gives at least the essentials for sending and receiving mail. But just as a little background, some design goals and simple to use, because what was there was not simple to use. I didn't understand it. I went in one day and tried to configure a connection, and I was just not getting it. So we needed something simple to use that was clear, a simple interface, a client, interface. Also, another thing was, there's a huge number of specifications for some of these. IMAP, for anybody that knows IMAP, is there's a number of RFCs there, which are the kind of the specification for IMAP and how it's supposed to work, along with all the extensions. And we have something like 20 plus extensions that we put in. So it's and as I did a tour with Python, this is highly inspired by Python, but it's also .NET's MailKit and some others that I kind of toured around and looked at. Well, what is everybody supporting? I kind of looked at their systems in terms of what people were asking for and when they delivered it and how, just so I could get an understanding of. I didn't want to implement RFCs that nobody used. So there's a lot going on there, very rich behavior, and the same is true for SMTP as well. Although that spec is not quite as big, it's a simpler spec. But even the basics like SSL TLS, it seems pretty basic to us today, but that wasn't there. And it wasn't easy to do that with the abstractions that were in place. But another thing that was really important was this more generalized security framework, SASL, which extends above and beyond mail. It's a more generalized authentication framework for internet protocols. And so we have a framework now that's in there. As I said, it will be pushed up even further to accommodate LDAP and some of the other places you can use SASL authentication, but that was a much needed feature. So some of this was, if you caught my talk yesterday, some of this is from that. We're going to go through this anyway, so I won't spend too much time. It's just kind of rattling off the various extensions that we put in. The really neat one about IMAP, and we can test it out at the end. I'll see if any of you want to shoot an email at a particular place. I can just put it in idle mode, and we'll see if the messages come flooding down. So for IMAP, and just just to cover the basics. And most of you know this, if not programmatically, from just configuring your phone or your, where IMAP is the protocol for you logging into your mail server and kind of getting mail, folders and listing things and doing and kind of pull-like actions. And then SMTP, I'm sure you all know, is the you configure on your phone for Gmail or whatever. It's the way you push send mail to other folks. And so now we're doing the same stuff, we're just doing it programmatically in a workspace. And so SASL support is this authentication framework. We're able to support a lot of these out of the box just because we have a really phenomenal crypto library that's binding on OpenSSL, but it's a very high-level binding that takes care of a lot of the issues across all the versions of OpenSSL, the ones that aren't too dated at this point. So and OAuth too are for things like Gmail. So a lot of things out of the box, and for something, even if we don't support a certain login authentication type, that last one there, which I'll show you an example of, there's a custom SASL builder which basically allows you via Smalltalk blocks to basically define how the SASL for that particular type works. And so even if we don't support it out of the box, you can still get at it without having to hack the system. And we also support SASL IR. So one of the things that as you're logging in, and there's this whole client and server exchange, and the nice thing is I'm going to show you, you're going to be able to see it because we have a logging capability that will kind of show client and server communications back and forth. So we're going to see what it looks like to log into a server and send a piece of mail, or pull a folder down. And so one of the things that we support is the SASL IR, which is the initial response, and that's a way to just basically inline all the credentials and stuff, so you need less back and forth. So it's just a more efficient way to authenticate. Okay, and with that we're going to jump in, and I'll just take a moment to make sure that everybody can see the font sizes and stuff. This I can certainly bring up. Oh, did it disappear on me? Let's see. Let's just do this. Has it been gone the whole time, or was that just? Okay, there we go. It's like, thanks a lot, guys. So. I know. Hello, right here. So it's a long night last night, right? All right, so is that font size pretty good? So in that case, I'll see if I can just go in general to, let's see if I open one of these guys, I'll try to match that. So maybe that's a little bit more, something like that. Okay, and then I got let's make sure we've got, so I'm going to kind of refer back to this test mail place I got going on. So that's now nice and empty. And this will be the transcript where we will see some of the back and forth. So what we have is, obviously this is a new feature. And so usually, you could document APIs and things like that, but I did the same with the OpenSSL bindings. I think it's much nicer and much more amenable to folks to actually learn by example with these. And so we have email examples. So all these are runnable in terms of you just need to define, so IMAP, for example, you just need to define what you're logging into and your user pass, and then you're able to load all these examples. So I'm going to be logging into just a test Gmail. It's just this, this test site I kind of created, and we'll go through. I'll walk through some of the examples and what they're doing. So we'll actually run one, or run a few. So let's look at some of the examples we have here. So checking capabilities. Let's do that one. So example capabilities. And what I'm going to do is I'm going to run this, and so this has logging turned on. So we have a plugin framework into the mail app. So both SMTP and IMAP have plugins. You can write your own plugins. And so the plugin I wrote, the first one, was logging. And so when you enable logging, it basically just adds a plugin for logging. And the nice thing there is under the hood, you might have an SSL/TLS, you might have a compressed, compression stream, a whole bunch of stuff but this has the hooks at the appropriate places so that it can, you can see what the actual exchange is. So I'm going to go ahead and run this real quick. And, oh, that one doesn't have the, let me see. Let me do another one. I'll do the SASL one. Okay. So we'll just take a quick look at what a client-server conversation might look like. And so over here you see a C, that's us, the client, and anything with the S will be the server on the other side. So you'll see the first thing is we request an authenticate, and then it comes back and says, okay, then this is, and we used SASL IR, so we got this all done in one line, as opposed to, hey, I want to authenticate. Okay, what do you want to be? And then you come back and I say, I want to do plain authentication with this. And okay, well, so we did it all in one shot, and that's what the SASL IR piece does. And then it comes back and it says, cool, capabilities, here's what they are, you're authenticated. And then we say, okay, now I want to request compression. And so we have and I showed this off at ESUG, was our really cool compression framework. We support, LZ4, Brotli, Z standard, gzip, zips, zip, deflate, all of them. And so this has under the hood, it just replaces the stream with the compression stream. And so now we get nice compression back and forth. It says, okay, and then I just logged out because it was just showing the actual authentication part. So now let me show you what that would look like, programmatically. So as I debug here, wow, this is big font. Okay, so let's go here, and I'll just reset this. Okay, so the first, and actually you don't normally need to do this, and I'll show you how we have an actual high-level login API from the client that will kind of figure out it goes from the most secure type of SASL login to the least, and it just rattles through until it gets the one that works. But here we're going to explicitly request a specific type of SASL login, which is the plain authentication, and that does nothing more than kind of appends your username and password, and base64 encodes it and sends it across. So we just create one of those, and this is the nice part now with the IMAP client. It's very much like our HTTP client, as will the SMTP client be like this, as you just say, it's the same API. For URL, give it the URL, and then we go in here, and so we're going to enable logging, and that does that, adds that plugin, and we just say, start up and then authenticate, and then it's going to shut itself down. And so once we do that, and that's the end of it. And then you log out, and it says log out and bye-bye. So that's the way you might actually log in and stuff. Now, a more interesting example. Let's actually have something up that we can see. So we'll do. Let's do a create, rename, delete mailbox. And then I'll kind of bubble back and forth between this view and the view up in the web browser, so we can get a sense of what it looks like. So I'll go ahead and debug. Okay, and then it's the same thing. I'm just going to create an IMAP client. I'm going to enable logging so we can all see the conversation going on. I'm going to log in. Now this is where the magic kind of is. I just have the user pass, and I'll kind of I'll go down into here. So now in the login high kind of API, and you're going to be able to see like the decisions that it's making in terms of how it's going to choose what way to log in. So well, it says, well, I need to call startup. So now you don't have to call that. And then it says, okay, well, I need the capabilities. I need to traverse the capabilities of the server. So there's this message that it asks for. And it's got this list of, this is everything the server reported as far as its capabilities. And usually that translates to extensions. Remember I mentioned those RFC extensions. Well, not every server supports, every single extension. So here we're looking for, basically the auth. What kind of authorizations do you actually, and so this is a Gmail site. And so we get the list of that, and then we have our own list of preferred authenticators, which is going to go from the Scram family, SHA-256, 1, MD5, to plain, to login. And it's sort of kind of going to go through and just try to match up the best one. And so once it gets, so the preferred auth in this case will just be plain because Gmail doesn't support Scram. Now normally we might do an OAuth 2 token exchange, but that's a little more complex to show. So in this case, we got the one that we want, and then we just kind of go ahead and authenticate. So you can see that kind of happened in the background there. And now we're gonna, okay, so now we have our client, and we're gonna create, and so each one of these APIs is documented in terms of what it does, the RFC it came from, what the response message is going to look like. And so let's go ahead and create this mailbox here. And you can say, okay, well here's what happened. Did it create? Now if we go back up here, and I do something like this, we see example, create, rename, delete, mailbox. So I just created a mailbox. Now the next one is, and then you can always check, did that go okay? And now the next thing I do is I'll just rename it, and I'll rename it to, with a 1 at the end. And we can see that translated to a rename, and that's what got sent across the wire, and it said, okay, that worked out. Hopefully it did. Okay. And now I see a 1 at the end. And so now after that worked out. And this is just a couple other, different APIs just showing that they work. And now we'll just get rid of it. So now this is how a delete of a folder would work. It says delete, says okay, that worked out. And so now if we refresh, that should be gone. So there's pretty much IMAP, and then I'll show, we can just resume this, logged out, everything's good. And let's see, where was I with this? Okay. And now we'll do an append. We'll actually append a message to our mailbox and then delete it. And this gives a chance, we have a number of builders for some complex search queries. So this will kind of show an example for the first time of what kind of, in Smalltalk you get to use the builder pattern for this, but how it kind of builds out the query that you're going to send over the wire. So let's go back here, we'll erase this. I'll go ahead and debug this. Okay, so we go ahead and log in. We're going to go ahead and ask what the append limit is, this is more just informational, just to show the user. So that's the max number of bytes that you can basically append, that Gmail will allow. Then we're going to create a sample piece of mail. And this is, it's in that kind of standardized mail format, and this is what we're going to send basically up to our mailbox. So this is a little different than like an SMTP. This is really an appending. IMAP supports, appending a piece of mail to your mailbox. So append to my inbox. This is what it looked like over the wire. We support some special extensions to make this inlined. So this tells it how many bytes ahead of time. And so we got it up there. So now if we go back, here's our mail. Okay. And now that says okay. Now it supports flagging, or you can put different flags on there. So if we did, and date and time as well. So let's see what one of these might look like, where I just did one where I append to the inbox and mark it as flagged. Okay, and that's what the star is in Gmail. Okay. So there's a number of different, when you do these things, there's a number of different flags you can set. And even deleting a piece of mail is setting a flag on it. That's how it kind of translates down. So that's that part. Say OK. We select the inbox, and here we're going to do a query. And this is the part I really like, because there's some cool builders in here that make this really easy. So select inbox. Messages have, we don't spend too much time, but messages have either a unique ID kind of associated with it or a message ID. And one's not unique, one is. So if you ever want to search by UID, which is the unique one, versus the message ID, all you have to do is, before you send the next message, just send the message UID. And now the next one, it will go into a state where the next one will send back the results in terms of its UID. So here, okay, so we're going to do a search. So the client object, we're going to request a search, and it expects a search criteria. But we want to build a search criteria, so it kind of looks like this. We ask the client for a new search builder with the following subject, something we haven't seen, so it's unread, sent since today. And then to make sure things are going to work out, you can just highlight it and inspect. And this is what it's essentially going to turn into. Subject, that, unseen, sent since, and then the date. And so that makes it really easy to do. The searches, there, and I'll just show you quickly what the API looks like. It's pretty extensive in terms of what you could search on. All these different things, you can just kind of add them up and build up a very complex query. And so we'll just resume past this, because I want to get to SMTP real quick before I put it into idle, and then we can do a little test message. But you can see that here. So here's the search. Here's some results of what it's sending back. So that's the bottom line. So this client now is just really simple to build all these queries, get mail, make folders, pull folders, all the basic stuff that you'd want to do. And SMTP is just the sending mail part. In fact, we'll look at it down here. What I'm going to do now is so this is the email address. Oops. This is the email address right here. And let me put it into idle first. So what I'm going to do is I'm going to create a new IMAP client. I'm going to log in, I'm going to select the inbox, and then I'm going to put it into idle mode. And idle mode means that it keeps an open connection going, and you've seen this on your phone, I'm sure, what they call push, server push, so that it's a sufficient way and you get your mail instantaneously. Because normally with an IMAP, you log in, you got to get your mail, and you log out, and then 10 minutes later, your phone will log in, get the mail, log out. So this is the equivalent of what you may see on your iPhone as push, or that kind of stuff, or Android. And what we send in is a block. And so we'll get a message, and you can do whatever you want with your message. So let's go ahead, and I'll put this into idle. And I'll go ahead and do this. Okay. So if you guys want to send an email, I'll send one of my own just so we can test it too. You should start seeing in the transcript, and there may be some delay as it goes back and forth, but there should be in the transcript, you just start seeing messages being received. And here I'll send one to myself as well using the SMTP client. Okay, so there's one maybe for myself that just came in. And so so basically it's just sitting there waiting with an open connection. Yeah, there's one. Another one came in. I didn't put a CR, sorry. So somebody else sent one. So it's just sitting there doing that while while your application processes it. And so it's pretty nifty because it just keeps an open connection going in the background. And yeah, that's it. Cool. Thank you. Oh, another one.
So there is a detail that caught my attention because when you log in, you have to pass the username and the password.
Yeah.
And so my question is, how do you resolve this? Because what I found is that the password is problematic, because if you have the password as a string that lives in object memory, there is the risk of the garbage collector moving that around. And then if you clean up the memory, you still leave traces of the previous location.
Yeah, so, I mean, what I would do personally, if I were really paranoid, which I am, would be to use our secure memory from OpenSSL. There's a secure memory arena, essentially, that's page guarded, and it's external memory, OS native memory. And the way you get it in is you can't mem copy or do, you gotta, one byte at a time type of thing, which somewhat obfuscates it, but the problem is you have to send it over the wire. You could probably get it down to a point where, right at the edge there where it's in its memory and now you gotta get it in the socket, going across, hopefully unbuffered. I mean, you'd really have to pay attention to that detail, but as far as just getting it out of the heap, you could do that with an OS string, and then when it's time to push it in the socket. The problem is buffering sockets, or it just depends what your threat level is in terms of how far you want to take that. Yeah. But another thing is the OAuth 2, for example, is the token exchange type of deal. Then you don't need your password necessarily, though there's some other private information. It's a good question. You can get it out of the heap, but that doesn't end the story. But.
No, yes. For instance, if you have your password in the heap, then it doesn't move. But if your code, without noticing what you are doing or what it is doing with that piece of memory, performs any operation like for instance, you put usually one has some structure to contain both the username and the password, like an association in your case. If then you want to transform that association, then maybe you perform some operation on the string that the result comes to
sure.
object memory. So there are many details you have to pay attention. So
yeah, so like I said, we have a special OS secure string,
okay,
which is designed for kind of that case. But I could still come up with a few scenarios where when it hits the socket, you may still be exposing some information. So
okay,
but yeah.
Okay, thank you, Seth.
Thank you.